In this video, as part of a Bayesian learning, we shall study Bayesian optimal classifier. Earlier we considered the question, what is the most probable hypothesis given the training data? In fact, the more relevant question is, and a closely related question is, what is the most probable classification of the new instance given the training data? Although it may seem that the second question can be answered by simply applying the map hypothesis to the new instance, in fact it is possible to do better by going for what is the most probable classification of the new instance given the training data. Consider a hypothesis space containing three hypotheses, H1, H2 and H3. Suppose that the posterior probabilities of these hypotheses given the training data are 0.4, 0.3 and 0.3 respectively. Thus, based on map hypothesis principle, we will say H1 is the map hypothesis. Now let's say a new instance X is encountered. Sorry. Now let's say this will be classified positive by H1 but negative by H2 and H3. Taking all hypotheses into account, the total probability that X is positive is 0.4. That is the probability associated with H1. And the total probability that it is negative is 0.3 plus 0.3, which is equal to 0.6. So taking all the hypotheses together, we find that the most probable classification in this case is negative classification, which is different from the classification generated by map hypothesis. The map hypothesis generated classification is positive. Now we state a new principle. The most probable classification of the new instance is obtained by combining the predictions of all hypotheses weighted by their posterior probabilities. Let's see the expression. In general, the most probable classification for an instance is obtained by calculating weighted sum of conditional probability of classifications given. In general, the most probable classification for an instance is obtained by calculating weighted sum of conditional probability of classifications given the hypothesis. The weights are probabilities of hypothesis given data. The weights are probabilities of hypothesis given data. Let's consider a set of classifications capital V. The probability of data being classified as Vj is given by P of Vj by D. P of Vj given D is equal to sigma H is an element of capital H, P of Vj given Hi into P of Hi given data. That's what the weights are, probabilities of hypothesis given data. So this is the weight. So we call it as, this is the weighted sum of probability of the classifications given the hypothesis. So P of Vj by capital D is equal to sum over all the whole hypothesis space, P of Vj by Hi into P of Hi by capital D. Now what is the optimal classification? The optimal classification of the new instance is the value Vj for which P of Vj by capital Vj given D is maximum. That is argmax Vj, an element of capital V set, and sum of P of Vj given Hi into P of Hi by capital D. The sum is to be carried over or carried out over the capital H space. Now let's see an example and understand. Let the set capital V be plus comma minus. So there are two classifications. Let the given probabilities be as follows. P of H1 given D is equal to 0.4. P of negative classification given H1 is equal to 0. P of positive classification given H1 is equal to 1, and the summation should be equal to 1. So P of H2 given D is equal to 0.3. P of negative classification with respect given H2 is equal to 1. And then P of plus given H2 is equal to 0. P of H3 given D is equal to 0.3. P of negative classification given H3 is equal to 1. Then P of positive classification given H3 is equal to 0. These values will apply into the expression, this particular expression, and this expression we have to calculate. One is for plus, another one for minus. So sigma hi, an element of capital H, P of plus given Hi into P of Hi by capital D is equal to 1 into 0.4 plus 0 into 0.3 plus 0 into 0.3, which comes to be 0.4. Now for negative classification, sigma Hi, an element of capital H, P of negative given Hi into P of Hi by capital D. In the similar way, we can get this value is equal to 0.6. Now we have to go to the basic expression arg max Vj, an element of capital V, summed over the H space, P of Vj by Hi into P of Hi by capital D. So the maximum is coming for the negative classification. Hence, as per this algorithm, the classification will be a negative. Any system that classifies new instances according to the above equation, that is arg max Vj, an element of capital V, sigma Hi is an element of capital H, P of Vj given Hi into P of Hi by Hi given D is called a Bayes optimal classifier or Bayes optimal learner. No other classification method using the same hypothesis space and the same prior knowledge, that is prior probabilities, can outperform this method on average. This method maximizes the probability that the new instance is classified correctly given the available data, hypothesis space, and a priori probabilities over the hypothesis. So this is about Bayes optimal classifier or Bayes optimal learner. I hope you could understand this concept clearly. If you like this video, please give a like for this. Thank you.